All right, so we are going to do some graphing of exponential functions and logarithmic functions. And yes, we are going to be doing transformations, so buckle up. The first thing we're going to do is graph 2 to the power of x. And I'm going to go ahead and put in my y values that correspond with these x values. I'm going to graph all of our exponential functions in purple because we're going to be comparing them with logarithmic functions, and I'm going to do all the log functions in pink. So just giving you a general sense of what 2 to the power of x is going to look like. So this is a growth function. We have an asymptote at y equals 0. My domain is going to be all possible x values. Everything is valid. And my range will be not equal to 0, but 0 is the closest we're ever going to get to. We're just never going to get there because of that asymptote. So my range would be from 0 to infinity. Now, I have this log function that we're going to look at. And based on what we did yesterday, if this was y equals 2 to the power of x, and I'm going to rewrite that, this would be log base 2, which is this function here. So this is showing me that these two functions are inverses of each other. So the first way I'm going to graph this is I'm actually going to take my x and y table from my exponential, and I'm going to go ahead and switch them. Since they're inverses, I can invert the xy table. And I'm going to graph this on here, and then we're going to look at this actually in Desmos so that you can see. So a fourth would be -2, and then a half, 1, and then 2, 1, 4, 2, 8, 3. And of course the screen froze. So that's one way to graph it, is just inverting the xy table from our exponential function. We could also, I'm going to turn this one off first, reflect my exponential function across the line y equals x, because remember, if it's a reflection over that line, they are inverses of each other. And now when I turn on the log function, you can see that these, the red and the purple, are in fact reflections of each other. So in the slideshow that has been shared with you, hopefully, you will have a link. This link right here will bring you to a Desmos screen where you can investigate all of these different shifts. These we did in Math 2. So we're going to look at how these reflections, or excuse me, these transformations in exponentials also affect log functions. So the first one we're going to look at is this -2 to the power of x. And thinking about what this is going to do, if the coefficient is negative, this is going to reflect over the x-axis. So instead of being up here in quadrants 1 and 2, we're going to be down here in quadrants 3 and 4. So all of these original y values are just going to be negative. So before I had a fourth, a half, 1, 2, 4, 8. This was if it was just 2 to the power of x. Now because this is negative, I'm truly just making all of these negative. So graphing these, -2, -1/4. So the shape of this graph, the curve, so to speak, or the shape of the curve, hasn't really changed at all. The only thing that's changed is that instead of being in 1 and 2, it's now in 3 and 4. So talking about our domain and our range before we do our log function. Well, my domain isn't changing. It's still all of my valid x values, everybody. Range is now everything below. So this is actually going to be -infinity to 0 now. So I had a ruler here somewhere. When I do this log function, I'm going to graph it first and then talk about what that log function would be. So this is my line y = x. Well, you can't see that, can you? And I'm just going to invert all of these points and graph them as this being my x column and this being my y column. So I'm graphing these inverted. So -8 is going to be at +3. -4 is going to be at 2. -2, 1. 0, -1. Oh, excuse me. Lord Jesus. -1, 0. -1/2. And -1/4. All right. Pretend that one pink dot isn't there. Minor brain fart. All right, so you can see that if I took this purple function and flipped it over the y = x line, I'm going to get my pink function. Now, in terms of my original log function, all of the output values are the same, but what changed was my input values. Now, I truly don't believe they are going to make you write log functions, but what we're going to do is look at what's actually happening. So before it was over here in quadrants 1 and 4, and now it's in 2 and 3. So the log function actually reflected over the y-axis, and what's happening is I'm starting with the same basic log function. However, instead of the negative being applied here, the negative is applied to our x value because I'm changing all of the x values before I get my output. So talking about domain and range, looking here at my pink function, it's all of my negative values up to 0, which is exactly what the range was from my exponential. And remember, if these are inverses, these are flip-flopped. All right, so there's one. Let's go on to this one. So if I am switching something with x, and I'm making some type of effect on x, that is a side-to-side translation for my exponential function. So this is actually going to translate, remember it's the opposite of what I see, so it's going to be left, oops, because I can spell, 3 units. And so what I'm going to do is I'm going to wave my teacher wand for just a second. I'm going to keep my same output values, and I'm going to see what X values are going to give me these same output values because I'm just shifting everything left. So before I was at 3, 8, excuse me, because I'm doing the original function. If I'm moving this original point, which was the last point in my first table, if I'm going left 3, 1, 2, 3, well, that's going to put me at 0. The next one was 2, 4. Moving that left 3 is going to put me at -1. And this is going to follow suit because we always did these in numerical order. And this is going to show me that left shift of 3 units. So I'm just going to graph this super quick. And you can see I have the same output values that I did before. They just shifted everybody left. So now preparing myself for this reflection that's about to take place. Remember, this is our y = x line. Now in this case, the domain and range have not changed. Domain is still going to be -infinity to positive infinity. And my range is still going to be 0 to infinity, none of that inclusive. When I do my log function, I'm going to switch these. So I'm going to do 8, 0, 4, -1, 2, -2, 1, -3, a half, -4. All right. So based on this transformed exponential function, this is the log function that I get. And I'm going to bring back my original log base 2 of x. And of course, the screen froze. If you look at our original point that was at 8, we had a y value of 3. Now my x value of 8 has a y value of 0. So my exponential function shifted left, but my log function translated down the same number of units. And this is because of that reflection. If something went left or right here, when I flip it over, it's going to move up or down. So left and down go together. If this went right, this should go up. So in terms of domain and range, this is not changing either. This is still going to go from 0 to infinity for domain and -infinity to positive infinity for range. But since this is moving down, if I think about what my log function would look like, I'm not tweaking my x values. I'm not tweaking what input values I had. I'm tweaking the output values, which means I'm subtracting at the end before I get my final output. I've got 2 more that we're going to look at. Maybe. All right. So let me make sure I've got purple. Dealing with this exponential function, we're going to do a transformation now that is down 3 units. So now it's not the x values that are changing. It's the y values that are changing. So I'm actually going to, wherever my original log function is, here it is. I'm going to take my original function here, and I'm going to take all of these numbers, and I'm just going to subtract 3. And that's how I'm getting these output values. So this is going to be negative 2.75. It's going to be negative 2.5, negative 2, negative 1, 1, and 5. So all I did was took my original output values from 2 to the power of x, and I subtracted 3. So I'm going to graph this really quick. Negative 2 is at negative 2.75. 0 is at negative 2. 3, 5. So same original curve, just bumped down 3 units. Now this is going to change our asymptote. It's no longer at y equals 0. It's at y equals negative 3 because I've shifted the whole thing down. So this won't change our domain, but this is going to change our range because I bumped it down. So let's see how that affects our log function. Now before, when my exponential function went left and right, my log function went up or down. Now my exponential function went down, so it would seem to reason that we're going to go left or right. So I'm going to graph these in reverse order. So I'm actually going to start here at 5, 3, 2, nope, 1, 2, negative 1, 1, negative 2, 0, negative 2.5, negative 1, negative 2.75, negative 2. So this is with the x and y coordinates switched. So looking at, where's my original log function? Looking at my original log function here, this original point was at 8, 3. Now it's at 5, 3. So I did in fact translate left. Our domain is changing. Now I'm starting at negative 3. I'm not starting at 0 anymore, which is the range from my exponential. And now I still have the same range. I'm still going up and down forever. So when I create this log function, I am changing my x values. That's going to be very similar to what we did with our exponential function, and it's going to change what's happening inside of the parentheses with x. Now remember, if I'm moving left, I write the opposite. So this is going to be x plus 3. All right. One more. Now if it's a half, and I'm actually going to graph this one in Desmos. I'm going to be lazy. Is that all right? I'm going to turn this one off. Ugh, maybe I'm going to graph this in Desmos. Took the struggle bus this morning. Okay. So a few things I notice. This is now a decay. but the domain and range are still the same from my original exponential function. And I'm writing some of these things down, and I'm going to share them with you on the screen in just a minute. Let's make a table of this. So you'll notice I have the same x values and the same y values, but they're inverted. So if I put, I'm just going to add -3 in here so you can see -3 is actually what would give me 8. So I'm sorry, I'm writing these down on my, let me go back to my original screen. So this is 1, 1 gave me a half, and 2 gave me a fourth. So here's my domain and range. This is a decay model. So if I was going to graph my log function, I would be at, well, let me graph my exponential quick just so you can see the comparison. -1, 2, 0, 1. Okay, so here is my exponential. And now I'm going to flip these. So I'm at 8, -3, 4, -2, 2, -1, 1, 0, a half, 1, a fourth, 2. So that's totally inverted as well. Our domain and range are still going to be the same for this log function. But what we have to figure out is how I'm going to make this log function. And I'm actually going to do a little experimenting here on Desmos. So I know it's not this. Before my base was 2. So what would happen if I put the 1/2 here? Oh, but not like that. Oh, it helps if I put the, y'all, sorry, I'm on the bus. 1/2. Oh, why won't it let me? Okay, I'm going to put 0.5 since it hates me so much. Now, you can see, because I changed the base of my exponential, I also had to change the base of my logarithm. And now I have my inverted function. So all of the other transformations we did, so this would be log base 1/2 of x. That's my log function. So all the other transformations we looked at did not affect the base, and I had to tweak some other part of the exponential function. Now that I'm tweaking the base of my exponential, I'm also tweaking the base of my logarithm.